Hey guys, welcome to our YouTube channel. It's me, the math god here, and Chavez. We're gonna be doing a UH quiz today. Be sure to like and subscribe after the video. This one's pretty tough, so good luck.
And correction, it's my YouTube channel.
No, it's my YouTube channel.
But, okay. All right. So here we go, guys. Let's get into it. Hashtag math life. Hashtag let's get this done. Hashtag let's win here. So let's see. Find the rate of change of the area of the circle with respect to the radius r. What is the rate when r is 7? So let's see. Area of a circle is just pi r squared. I'm going to change my sensitivity here. Oh, it's already in tablet mode. All right, so area is pi r squared. So that means I'm taking the derivative with respect to r, because it says with respect to the radius r. So it's going to be 2 pi r, and that's it. So now I'm going to plug in dA dr when r is 7. And 2 times pi times 7, and you get 14 pi, and that's it, guys. Sorry, guys, I had some coffee here. All right, here we go. Next one. The area of a sector in a circle is given by the formula a equals 1/2 r squared theta, where r is the radius and theta is the central angle measured in radians. Find the rate of change of theta with respect to r if a remains constant. What is the rate when r is 4? Okay, so I think the easiest way to do this, guys, it says find the rate of change of theta with respect to r. So the easiest way is to get theta by itself. That way you can take the derivative of that. And remember that a is constant. So I'm going to multiply by 2. So when I multiply by 2, I get 2a equals r squared theta. And then to get r squared out of there, I just divide by r squared. So I get theta equals 2a over r squared. But I don't want to have this in the bottom. Remember, 2a is a constant. So I'm going to rewrite this as 2a r to the negative 2. All right, so now I'm taking the derivative of theta, but I'm taking it with respect to r. So d theta dr is equal to negative 4a r to the negative 3. So rewriting, you get 4a over r cubed, and then we look for that. So let's see. That one's done, and that one's done. So immediately the only one is letter B. But, let's still keep going to make sure that we get this number. Obviously, it is possible, so it can't be letter A. But let's continue, guys, anyways. So d theta dr, when r is, what is r? When r is 4, so you get negative 4 over, negative 4a over 4 to the third power. So one of these 4's cancels out, and now that's 4 squared. So now let's see what I have. I have a negative a over 16. So there it is. Negative 1 over 16a. Cool. All right, let's go to the next one. An object moves along the coordinate line. Its position at each time t greater than or equal to 0 is given by this function. Find the position when time is 7. So since they just asked me what's the position at t equals 7, I'm just going to plug in. And it looks like it's that straightforward. It looks like x of 7 equals negative parentheses 7 squared. The negative's on the outside, guys. Plus 2 times the negative 7 plus 3. So negative 49 minus 14 plus 3. No. Now, let me read it again. An object moves along the coordinate line. Its position at each time t greater than is given by x of t. Find the position at time t equals 7. 49.
Why'd you put negative 14? It should be positive 14.
Oh, yeah. Why did I put negative 7? Dummy. Sorry, guys. Technical difficulties. It's been a long day. It's 7:16. I'm still here at school. Not that this is considered a long day, because it hasn't, but, well, I guess it has, because we just did testing this morning, right? Air punch. You can't see it, but I did an air punch to you guys, which, no offense. Don't get mad. All right, here we go. An object moves along the x-axis. Its position at each time t greater than or equal to 0 is given by x of t equals blah. Determine the time intervals, if any, during which the object slows down. All right, you slow down whenever the velocity and acceleration have opposite signs. So that's all I'm going to do. I'm going to find velocity, I'm going to find acceleration. So here we go. V of t is equal to a negative, let's see, 1/4 times 4 is -1, so negative t cubed plus, let's see, 75 over 2 times 2 is 75, 75t. I'm going to factor out a t, and if I do that, I'm going to get a negative t squared plus 75. So let's see what t values I get from here. I get 0, t equals 0, and let's see, t squared equals 75. If you set this equal to 0, guys, so then that means square root, and I know that 75 you can get from 25 times 3, and 25 is a perfect square root, so that means the square root of 25 is 5, so t equals 5 square root of 3. So here's my number line for velocity. And my only critical numbers are 0, so I started 0, and 5 square root of 3. All right, so now let's do acceleration. I'm going to do that in blue, guys. Acceleration, a of t, is equal to a negative 3t squared plus 75. I'm going to equal that to 0, so that's where the sign change is going to happen if there is. So let's see, 3t squared equals 75. When you move the 3t squared to the right, and then I write it first in the left-hand side. Divide by 3, so you get t squared equals 25, and then square root, t equals plus minus 5. Of course, you only care about the positive one. So, let's see, here's mine, and 5 is a number smaller than 5 times the square root of 3, so I'm going to say 5 is like right here. See? All right. This is acceleration, and the one in red is velocity. So let's see. If I choose a number to the left of 5, like 1, negative 3 times 1 squared is negative 3. Negative 3 plus 75 is positive, so that means this is positive. And to the right of 5 is negative. Cool? Cool. All right. On the red one here, if I plug in a number like 5, so let's see, 5 squared is 25, negative 25 plus 75 is positive, so positive. And if I plug in a number like 10, 10 squared is 100, negative 100 plus 75 is a negative, so negative. So there we go. So where am I decreasing? Where is the object slowing down? Well, wherever the signs are opposite. So the signs are opposite between 5 and 5 squared root of 3. See, because at 5, if this is 5 here, my velocity is still positive, but after 5, my acceleration is negative. And then once you pass 5 squared root of 3, the velocity and acceleration are both negative, meaning that now you're increasing in speed. So the answer is between 5 and 5 squared root of 3. Cool. I hope you guys like that one. I thought that was pretty cool. All right, the next one. An object projected vertically upward from ground level returns to Earth in 22 seconds. Find the initial velocity in feet per second. All right, so we're doing this the calculus way, guys. Yes, you can do it with physics if you want, but it's easier with calculus. So what we're going to start with is we're going to say the acceleration due to gravity is 32 feet per second. So we're going to say that's negative 32 because downward is negative. So then what I'm going to do is I'm going to find the velocity equation. So my velocity equation, I have to do the antiderivative of this, guys. So that's something that we need to practice some more with. So my velocity equation is the antiderivative. So negative 32t plus c, some constant. And I know that velocity at 11 seconds is 0. And how do I know that? Because it tells me it takes 22 seconds for it to come back to ground. So at 11 seconds, the velocity is 0 because it takes 11 seconds to reach a maximum height. So it takes another 11 seconds to reach the bottom. So now knowing that, I'm going to say velocity at 11 equals negative 32 times 11 plus c. Cool? Cool. So 32 times 11, and oh, by the way, and we know that velocity at 11 is 0, so I'm going to say equals 0. So 32 times 11 is 352, so I have negative 352 plus c equals 0. Move the 352 to the right, and we get that c equals 352. Now that I know what my velocity equation is, v of t equals, let's see, negative 32t. Negative 32t. Okay, am I recording? Yeah, it's recording. Well, hold on. I got to make sure, guys, because I wasn't sure. Yeah, it's recording. Sorry. You can just fast forward this, I guess. Continuing. All right, negative 32t plus 352. And they want to know, find the initial velocity. Well, initial velocity just means v of 0. So v of 0 is, let's see, negative 32 times 0, 352. See? You just plug in a 0 for t. All right, here we go to the next one. All right, here we go, guys. A stone is thrown upward from ground. Hey, stop. A stone is thrown upward from ground level. The initial speed is 320 feet per second. All right, so that's the initial speed. So that means that velocity initial is 320. And then write feet per second there, like so. And then it says, in how many seconds will the stone hit the ground? All right, so what we're going to do again, acceleration due to gravity is negative 32. So my velocity equation, antiderivative, is negative 32t plus c. But I already know that velocity at 0 is 320 feet per second. So velocity at 0 is negative 32 times 0 plus c, which equals 320. So that means that c must equal 320. So that means, this means that c equals 320. So now I have this, v of t equals negative 32t plus 320. Now here's what we know. When the velocity reaches its maximum height, so when you throw something and you reach its maximum height, the velocity at that moment is 0, guys. So I'm going to equal this sucker to 0, and I'm going to see how long it takes for this to reach the highest point. So now just move this guy to the right, or the 320, it doesn't matter. Eventually you're going to get the same solution. So 32t equals 320, divide by 32, and you get that t equals 10 seconds. Now that's how long it takes to reach the highest. So if it takes 10 seconds to reach the highest, it must obviously take another 10 seconds to reach the ground. So total is 20 seconds. Cool, guys? Cool. All right, here we go. Another one. A particle is moving along the parabola x squared equals 4y plus 3. As the particle passes through the point 4,1, the rate of change of its y coordinate is 6 units per second. How fast in units per second is the x coordinate changing at this instant? So what they want is dx dt. So first write what you do know. So you have a point 4,1, and you know that the y coordinate is changing in 6 units per second. So that means that your dy dt is 6 units per second. How fast is in units per second is the x coordinate changing? So I'm going to be taking a derivative, but with respect to time. So here we go. The derivative of x squared is 2x dx dt. And if you want to distribute this, 4y plus 4 times 3 is 12. So there it is. So the derivative of that guy is going to be 4 dy dt. And the derivative of 12 is 0. Yeah? All right, take it easy. Everyone say bye to Miss Revilla. Bye, Miss Revilla. Okay, bye, that's guys. Everyone. And she says bye to you guys. So, all right, let's continue. Have a good one, Revilla. No, it's yours.
I don't drink soda.
Well, don't worry about it. Thank you, though.
I don't want. Okay, I'm buying one.
Okay. All right, here we go, guys. Sorry about that. Technical difficulties. All right, so continuing. We already have dy dt. Have a good one, Miss. We're looking for dx dt. We don't have that just yet. And we have an x value and we have a y value. We don't need the y value, so now it just becomes algebra. So I'm going to write 2 times 4 times dx dt, which is what I'm looking for, equals 4 times 6. So I guess to make life easier, I'm just going to cancel these 4's. Divide by 2, divide by 2. 6 divided by 2 is 3. So I'm going to start looking for an answer of 3. And there it is. All right, here we go. A heap of rubbish in the shape of a cube is being compacted into a smaller cube. Given that the volume decreases at a rate of 2 cubic meters per minute, find the rate of change of an edge in meters per minute of the cube when the volume is exactly 8 cubic meters. All right, so I know the volume of a cube is s cubed. So they're telling us what the volume is. The volume is 8. So from that, we can, let's see, 8 equals s cubed. From that, we can figure out that s has to equal 2. Next, they want how fast the edge is going. So I'm going to take a derivative with respect to t. So dv dt is equal to 3s squared ds dt. So next, so we already have the side. And we already have dV/dt. They tell us right here. The volume decreases at a rate of 2 cubic meters per minute. So that's -2 because it says decreases. So -2 equals 3 times S, which is 2 squared. And then they want to know what ds/dt is. So we're going to solve for ds/dt, guys. So here we go. Let me put this, it's a little sensitive. There we go. So I'm going to write -2 equals, I guess, well, no, we already started. 3 times 4 is 12, ds/dt, divide. So ds/dt equals -2 over 12, which reduces to -1/6. And there it is. All right, here we go. This one looked like it might take a while. We'll see. A rectangle is inscribed in a circle of radius 5, so the radius is 5 inches. If the length of the rectangle is decreasing at a rate of 3 inches per second, so the rate, so let's see, that's the length, so dl dt is equal to -3. How fast is the area changing at the instant when the length is 4 inches? So the length, they give us the length is 4 inches. Okay, so you have a circle, guys, and inside that circle you have a rectangle. There's my rectangle. Here's my radius. So that's my R, and that is never changing. So the radius is never changing, so that means the diameter is never changing. So the diameter is 10. But this circle, the circle itself is not changing. The dl/dt, the length of this circle, L and W. The rectangle is getting more and more looking like a square, I guess, or it's changing form. It's changing shape. The dl/dt is decreasing, which means that dw/dt, let's see, is that increasing? Or also, no, it's increasing. If dl/dt is decreasing, dw/dt is increasing, because you can tell, look, if I do this rectangle, see how dw/dt now is bigger, or w is now bigger than what it was. I'm going to try to erase very carefully here, guys. Maybe I shouldn't have done that, but just wanted you guys to see. All right, so here we go. So my relationship, the area is length times width. So I'm gonna do this first in red, guys. So dA/dt is equal to first times root of the second, dw/dt, plus the second times root of the first, dl/dt. So there it is. There's my dA/dt. Now I'm gonna find. Well, okay. Look, I have L. I do not have dw/dt, not directly at least. I have W, not directly, and I do have dl/dt. So how do I have W? Well, I see a right triangle right here, guys. So I know that L squared plus W squared equals, and the radius is not changing, remember that. So the diameter is 10 squared. So let's see. 4 squared equals W squared, which equals 10 squared. W equals the square root of 10 squared minus 4 squared. So I put that in my calculator, and I get, let's do that real quick, guys. 10 squared minus 4 squared. I get 2 square root of 21. All right, so now I have W. So now I'm still missing dw/dt. So I'm going to get dw/dt by, again, doing Pythagorean theorem. But this time, I'm going to take a derivative. So if it's okay with you guys, I'm going to do it right here. So I'm going to write 2L dl/dt. I'm taking a derivative, guys. Plus 2W dw/dt equals 0. I can factor out a 2, so that means the 2's are going to cancel out anyways, because 0 divided by 2 is 0. So then I'm going to move the I'm going to move the L dl/dt, so W dw/dt equals a negative L dl/dt. And let's see, what else am I going to do? I'm going to divide by W and divide by W. So let's see what I get. dw/dt is equal to a negative 4 times dl/dt, which is a negative 3, divided by W, which is 2 over square root of 21. So my dw/dt comes out to be, let's see, 12, 2, so 6 over square root of 21. And if you want to rationalize it, you can call that 6 square root of 21 over 21. So there it is. I think I've reduced it. So now we're ready. So check mark. So now, here it is. I'm going to plug it in, guys. I'm just plugging in. L is 4. dw dt is this guy. So 6 square root of 21 over 21 plus w is 2 square root of 21. And dl dt is negative 3. So I'm going to plug that in. So let me take my little calculator. 4 times 6 square root of 21. All that is divided by 21. And I'm going to add 2 square root of 21 times negative 3. And I get an answer of negative 34 square root of 21 over 7. I'm using a TI Inspire, guys, in case you're wondering how I'm getting these numbers immediately with them rationalized already. I'm using a TI Inspire. It shouldn't be too much difficult if you use like a TI-84 or Desmos or something. You should still get the same answer. You should still be able to figure it out. It shouldn't hinder you much. Spherical snowball. This one's exactly in the notes, guys. Exactly in notes. So let's save some time. Let's have you guys look at your notes. We did that question. It's verbatim, exactly the same. Maybe the numbers are different, but it's exactly the same type of question. All right. A 20-foot ladder is leaning against a vertical wall. If the bottom of the ladder is being pulled away from the wall at the rate of 2 feet per second, at what rate is the area of the triangle formed by the wall, the ground, the ladder changing, and I can't even read. It's formed by the wall, the ground, and the ladder changing in square feet per second at the instant the bottom of the ladder is 12 feet from the wall. All right. So what they really want to know, you might have to read that again, guys. They want to know. It looks like they want to know the rate of change of the area. So we have a ladder. So here's my wall, and the ladder is this guy in blue. All right, let's see, 20-foot ladder. So this is 20 feet, and it's not changing. If the bottom of the ladder is being pulled away from the wall, okay, so I'm going to call this X, I'm going to call this Y. So it's being pulled away from the wall at a rate of 2 feet per second. So dx dt is equal to 2. At what rate is the area of the triangle formed by the wall, the ground, and the ladder changing? Okay, so they want to know the rate of change of the area in square feet per second at the instant the bottom of the ladder is 12 feet from the wall. So at the instant the bottom, okay, so that means that X is 12. So that means we can get Y really fast. So Y has to be the square root of 20 squared minus 12 squared. So let's do that really quick, guys. 20 squared minus 12 squared. And that is 256, and that's a perfect square root, which is 16. I guess I didn't recognize that, sorry. So there it is. Oh, don't. Sorry, I almost made a mistake there. If you put the number on the picture itself, that means you're freezing it, which means it's not moving. So leave it with variables like that. All right, so Y is 16, X is 12. Area. So area is, let's do the area in red, guys. I just find red to be a color that just, it's just out there like bam. You know what I mean? Yeah, you know what I mean. 1/2 X times Y. So I'm going to do product rule. I'm going to bring the half on the outside like that. So I'm going to say dA dt is equal to, bring the half on the outside, first times root of the second, plus second root of the first. There you go. So let's see what I have. I have X. I have dx dt. I have Y. I do not have dy dt, at least not directly. So how I'm going to get Y, how I'm going to get dy dt is by doing Pythagorean theorem. So I'm going to do it here on the side, guys. So x squared plus y squared equals 20 squared. The 20 is not changing. So there's no reason, you can write z squared if you want, but when you take the derivative, it's always 0, the derivative of that, because it's not changing. So 2x dx dt plus 2y dy dt equals 0. So again, factor out the 2, divide, so you can cancel out those 2 like so. And then what we're looking for is dy dt. So I'm going to move these guys to the right. So y dy dt equals a negative x dx dt. So divide by y, divide by y. So my dy dt is equal to negative x. So let's see, what was x? 12. Negative 12 times dx dt, which is 2, all divided by y, which is 16. So negative 24 over 16, which reduces to 3 halves. And it's negative. That should not be a surprise, guys, because it's going down. So now I have dy dt, and there we go. We can plug in everything. So 1/2, and I'm going to just leave it like as is, and I'm just going to plug in 12 times my dy dt, which is a negative 3 over 2, plus my y, which was 16, and then the dx dt, which is 2. All right, here we go. So 12 times negative 3 halves plus 16 times 2, and I get 14, and I take half of that, and that is 7. So 7, and there it is. All right, let's go to the next one. Is this the last one? Last one, hallelujah. All right, a man standing 11 feet from the base of a lamppost casts a shadow 3 feet tall. If the man is 6 feet tall and walks away from the lamppost at a speed of 450 per minute, at what rate in feet per minute will the length of his shadow be changing? Okay, let's draw this. So this is a lamppost, L, and here is the man. He's pretty tall. Yeah, there it is. He is 6 feet tall, so that we can write in there. And hopefully you can see similar triangles right there like so, see? And his shadow is actually right here in black. That's his shadow there, guys. So I'm going to say S for shadow. That's not a 5, that's an S. And I'm going to say the distance from the lamppost to the dude, I'm going to say that distance is X. So let's see if we can do proportions, guys. They tell us that the shadow is 3 feet tall. If the man is 6 feet, okay, let's see, a man standing 11 feet from the base, so that means X is 11. If the man is 6 feet tall and walks away from the lamppost at a speed of 450, so that means dx dt is 450 feet per minute. At what rate in feet per minute will the length of a shadow be changing? All right, so what we got to do first, guys, we got to figure out the length of the lamppost. So let's do that real quick. So you already know this triangle here. So let's see, 3 is to 6 as, let's see, 3 is to 6 as x plus s. So that's 3 plus 11, 11, 12, 13, 14, as 14 over L. So let's figure out this first. 3L equals 14 times 6, which is 84, divided by 3, and you get 28. Since this is constant, I'm going to put 28 there. All right, so now that we got that, now we can go right into it. So now I'm going to write it like this, guys. S is to 6 as, because that is a constant, as S plus X is to 28. So now I'm just going to solve for that, guys. So I'm going to cross multiply. 6S plus 6X equals 28S. And I'm going to move this 6x to the right. I'm going to rewrite it first, guys. 28 minus 6 is 22, right? Yeah. 22s equals 6x. Divide by 22. Divide. X equals 3 over 11. Not x, s. Sorry, guys. S equals 3 over 11x. So now I'll just take a derivative. So ds dt equals 3 over 11 dx dt. So that's it. So there it is. So my speed, ds dt, of the shadow, is changing by, let's see, 3 over 11 times the speed that the dude is walking. He's walking at 450. I take my little calculator, and yeah, you can probably do it by hand, but I'm just going to take my little calculator. And I get 1350 over 11. All right, guys. I hope you liked this video. I enjoyed doing this video because it was actually kind of a lot of fun. Thumbs up to everyone who came by today and joined. I know Revia was here, and then we had a good crowd come in to just chill out. So I guess they were enjoying the middle school dance that's happening right now. So if you didn't go to the middle school dance, you're missing out. No, I don't know because I haven't gone over there. But anyways, I hope you guys are having a good time. I hope you guys are having fun. Hopefully you're doing a little bit of calculus because, doing calculus is always fun. And, I hope you have the rest good. I hope you have a good rest of the evening, guys. So I wish you guys the best. I hope you guys are happy, and I'll see you guys when I see you guys. Take it easy, guys. Let me see if I can start turning this guy off here. So you're going to have to wait a few seconds if you're still there. All right, later, guys. Bye.